Is there life on Mars today? It depends on whether or not there's liquid water on the planet. And the conditions on Mars don't look great for liquid water. It has less than 1% the atmospheric pressure of Earth, which means that any water will either freeze or boil, but you're not going to get pools of liquid water on the surface of Mars. It's bitterly cold. It is bathed in radiation. And so there's not a lot of places where water could be. And so scientists are thinking of unusual places where water could be. And there's one really cool idea that actually happens here on Earth. If you have ice that has been cleared off so that it's clear and the sun is shining, then at about 20 centimeters down, if there's dust mixed in with it, it can actually become a liquid and it's held in by the ice that's above it. And so this exact same situation could be happening on Mars. And in fact, scientists have found places on Mars where it does look like these conditions are happening, that there could be spots where you've got ice exposed to the surface, sunlight is warming it up, and you're getting pockets of water underneath the surface. And these could be places where life could survive. My guest today is Dr. Aditya Khuller. He is a senior research scientist at the Polar Science Center at the Applied Physics Lab at the University of Washington in Seattle. He and his team are examining compelling evidence that there are places on Mars where you've got these same conditions forming. Ice is being exposed at the surface, it could have water underneath, it's breaking through and causing gullies that are brand new, like within 10 years old. And so Mars could have pockets of liquid water here and there across its surface. Good places to go and send a helicopter and a rover. So enjoy this interview with Dr. Aditya Khuller. Aditya, how do we know if water can even be liquid on Mars?
Well, we don't. Unfortunately, but for the last 50 years, there's been a lot of debate as to whether ice can melt on Mars because it's two big differences compared to the Earth. On Mars, the overall atmospheric pressure is much, much lower. So on Earth, the average pressure is about 1,000 millibars. On Mars, it's something like 7 millibars. And
right, 1%.
Yeah. And then the other even more important aspect is how dry the atmosphere is. So it's about 0.01% or even less of water vapor in the air. So just like a glass of water on your table in Seattle or Florida will evaporate over time, but it'll evaporate even faster in Arizona, where it's very dry. And on Mars, it's way drier. And so there, depending on where you are, if you have ice at the surface, in equilibrium, when everything is stable, it should just turn into gas at the surface because there's so little water in the air. But
so look, if I was just to go randomly to any spot on Mars with a bottle of water and dump it out onto the surface of Mars, what would happen to the water?
It depends on where you are.
Oh, interesting. Okay.
Yeah. So, because if you're at the poles, it would probably freeze. Yeah, it would freeze and then it slowly turn into gas. And then slowly as in like millimeters per hour or less. So pretty slow. And then if you did it in the northern latitude areas where your pressure is higher than 6.1 millibars, the triple point of water, then there the liquid would, depending on the temperature, could still freeze. Otherwise, it would just evaporate. And then if it evaporates, it could still freeze after that because it's cooling. Evaporation causes cooling. Then if you're in the south where the pressure, if you're in an area basically where the pressure is lower than 6.1 millibar, then you could actually boil and bubbles would form. And then you might freeze again because but it would almost explode. Like it would happen as if you're at 100 centigrade in a pan of water. So it all depends on the local conditions. But then if you have snow or a bunch of ice, rather than a bottle of liquid water that you put on the ground, because ice is translucent, sunlight can go inside, heat on the inside, and potentially form liquid water inside. And we see this happen on the Earth. So that's what I'm trying to explore.
Right. Okay. And we'll definitely get to that. And at the same time, though, I've reported on many times where people have proposed different ways that maybe there could be liquid water on the surface of Mars for brief periods of time. Very briny versions of water where that brings down the melting point, boiling point, or that you've got something that is sort of, as you say, protected under some kind of surface, either a little bit or maybe kilometers of rock, and maybe you can have liquid water, something under pressure, and stuff that's maybe very seasonal, where maybe you have some shadow and it just the right time and the right season, you get a little bit of water and then it evaporates again. So, do any of those mechanisms seem feasible to you?
They may be feasible in limited areas, but the one we're looking at seems the most feasible. Which you said
And that is water under ice.
That's water. Yeah, I want to make it clear that it's within the ice. So let's say 20 centimeters within a glacier that's exposed at the surface.
Oh, okay. So, because I know that like here on Earth, you've got glaciers and the water, because of the pressure, you get this layer of water that almost acts like a lubrication for the glacier itself.
I'm not talking about
that.
No.
But do you think that is possible?
It could be possible. Yeah. Even on Earth, people are trying to figure out exactly how that forms, because it's the pressure alone is not enough. Actually, it's of the weight. I mean, it seems like it's friction and then also pressure from facets in the ground underneath. So there's local pieces of land that are pushing on the ice that generate more friction, and then also additional pressure from not just the top, but also from the underlying. So we're not talking about that. We're talking about, 20 centimeters into the ice, because the ice is translucent. It acts like a greenhouse kind of. Essentially, the ice is, like I said, translucent at where sunlight peaks. So all the sunlight is going inside, heating on the inside. But then when the ice is trying to get rid of that energy at the thermal wavelengths, like all of us at room temperature, we're emitting in the thermal infrared. So like if a snake was here, it'd be happy to see us because we're all emitting in the thermal infrared. But ice is very strongly absorbing in the thermal infrared. So that heat is trapped inside the ice. And if the conditions are right, it can be freezing on top, but melting inside. And we see this in Antarctica. It's rare, more rare on the Earth generally, because there's snow on top. And snow is very reflective. And so not much light actually gets to go deep inside. But in places where the snow gets blown off, like places in Antarctica, the bare ice gets exposed. And there people have been walking along, notice it's frozen at the top, but then 20 centimeters down to about a meter, there's liquid there. So that's the kind of depth we're looking at.
Yeah, and that's interesting. I was sort of imagining, like, say, a frozen lake.
Yeah, somewhat similar.
Right, and you've got like ice on top, and then the wind is blown any snow that's on it, and then you have like a really hot, sunny, like a warm, sunny day, and the light is coming through. You could get pockets of water that are sort of underneath the surface of the ice, and then sort of how is that then a link potentially to habitability of those areas?
Yeah, so I'm not a biologist, but from what I can gather, one of the key ingredients is liquid, and then the other one is energy. If it's photosynthetic life, then it'd be energy in the photosynthetically active sort of radiation between green light to red light, or blue light to red light. And then you don't want to have harmful radiation in the ultraviolet. And so we did these simulations where it seems like in ice on Mars, you can get to certain depths at which maybe there's liquid, and you could block out the UV that's harmful, but still have enough radiation for photosynthesis, especially if there's some dust in it, like small amounts, less than 1%. Most of the ice on Mars is dusty, from at least from what we can see from orbit. And again, dusty is like less than 1%, but dust is so strongly absorbing that it's the same on Earth. When you see snow and a few days later it looks black, you could take it home, melt it at home, and the amount of dirt is probably like 1% or less, just because carbon and dust are so strongly absorbing. So the dust can help block out the UV as well, and then leave behind some, but less helpful radiation for photosynthesis. So
Right. And I guess this overcomes one of the big concerns that people have. Like here on Earth, we're protected by this very thick atmosphere, the ozone layer. This is blocking the dangerous ultraviolet radiation from reaching the surface. And so,
Mhm.
beings can scamper about on the surface of Earth and not get destroyed by the ultraviolet radiation. But you go to a place like Mars, there is no protection, doesn't have that thick atmosphere. And so the ultraviolet rays are hitting the ground, theoretically sterilizing any life that's there on the surface. So how much ice gets you a similar amount of ultraviolet protection?
Um, Again, as usual, it depends, but it could depends on how much dust there is and how large the ice grains are, which increase over time. But it's on the order of centimeters to meters, depending on these different the dust content and how old the ice is, essentially.
But that
So
fits
not
within this same calculation that you are
yeah, exactly.
20 centimeters down, you're protected by the ultraviolet radiation, and this greenhouse effect is causing liquid water to be in the ice on
Exactly, yeah.
theoretically on
So there
Mars.
may be this Goldilocks zone where you have the radiation, harmful radiation blocked off, helpful radiation still there for photosynthesis, and you have liquid water. So that's what we're trying to answer is the liquid part, because the average Mars scientist might say, "Oh no, that liquid, there's no liquid there; it's impossible." But they've not done the calculations yet. So
Right. And then the dust mixed in, which potentially could have essential nutrients that
yeah, exactly.
and chemicals that the life could be requiring.
Yeah, because I should clarify, you mentioned brines earlier. We think the ice that I'm describing, at least, formed from snow, and which has a small amount of dust, and so there's no evidence so far that that ice has any salt in it. Maybe the soil around it has some salt, but the dust itself, we don't know if it has any salt in it. So the melting temperature, as far as we know, we consider as the same as on the Earth of pure ice, essentially.
And so where on Mars do we find ice that would meet this criteria?
Yeah, it's in the mid latitude, so between 30 degrees in both hemispheres to, let's say, 50 degrees or 45 degrees, because it's, again, this potentially utopian region where there's ice there, it's near the surface. We've actually seen it been exposed on these steep slopes over the last 5 years, and it seems to go away after 5, 10 years. And the ice is there and there's enough sunlight for the temperatures to get close to the melting temperature at the surface, which could mean below the surface it's melting if the conditions are similar to the ones on the Earth.
But we're seeing this ice in places where some geologic event has revealed it, right? Like some kind of landslide or something. So this ice. So where did this ice originally come from, do you think?
Yeah, so people think just like Earth, we've had ice ages on Mars. And on Earth, the way that it happens is Earth is going around in space, it's being pulled by the sun on one side and then Jupiter on the other side. And so it's wobbling a little bit, but then we also have the moon to stabilize us. And when we do wobble, the angle at which the sun is hitting either the poles or the mid latitudes is changing. But it doesn't oscillate much, again, because we have the moon. But every time it does oscillate by a degree or less, we have an ice age, and ice either encapsulates a lot of the planet or is mostly at the poles or mostly at the equator. So currently that tilt is about 23 degrees. Mars is also close around right now, about 25. But because Mars has two feeble moons, when it's being pulled by Jupiter and the sun, it oscillates even more wildly, like between 15 degrees to 45 degrees. And whenever that angle changes, you have this ice age. And so over the last few million years, that angle has oscillated a lot. And so we think every time that's happened, snow has either gone from the poles to the mid latitudes or vice versa, and eventually build up to where at the mid latitudes there may be 20 to 40 meters of ice or snow that is now gradually becoming a glacier. And it's all buried like a debris covered glacier on the Earth. And in these patches, like you mentioned, there are landslides or wind that could expose the ice, and that's what we're seeing.
Okay, like right now when we look at Mars, even in a small telescope, you see the polar caps, and they're a big layer of water ice that then has like a layer of carbon dioxide that accumulates and then sublimates as the seasons change, but that cap is there. And so you're saying that in these times, this happens fairly often, Mars's tilt is more significant, than the actual location of that ice cap is going to be in a different spot, and then that's going to be covered by dust and somehow protected, and then the ice cap. So these caps could be significantly larger under the surface, that we just can't see them except for these occasional spots, as you said, where you see this really cool. And I know that exactly the story you're talking about, where you see this like layers of ice on the side of a hillside, and just from this.
Yeah, that's one example. And then there are some examples in these gullies, which like ones you're talking about are higher latitude, like 45. The ones that are even more exciting than those are at 33 degrees south. I found them with my advisor, Phil Christensen. And they're more exciting because they're closer to the equator, so there's more sunlight. And they're, again, formed in these gully channels, where the channels are forming and then exposing the ice in these buried glaciers within them.
Wow. And what is causing the erosion in the gullies? Is just...
That's the other question. Is we think it's the ice gets exposed and is melting, but some people believe it's the CO2 that the atmosphere is made of. It freezes and then turns into gas, and somehow that can destabilize the slopes, which it probably can, but we don't know if it can actually erode and weather like rock. Like if you put a chunk of dry ice on the sidewalk, it'll just turn into gas. The rock underneath nothing will happen to it. So that's one of the big debates as well. Another.
And this is different from these interesting, almost these streaks that people have seen in the southern hemisphere of Mars. Yeah, totally different. Another possible. Yeah. I mean, I know that when those were first seen, people thought, oh, maybe this is water that's rushing out onto the surface and then pouring down the slope. And then people said, okay, no, maybe it's carbon dioxide. And now it's like, maybe it's just dirt. It's just sand falling down, and it's just fresh and it's a different color and no water involved. But this is something that looks like clearly the ice is being exposed by these gullies. So it doesn't seem that far of a stretch to think that the water is somehow having some kind of effect on this.
Yeah, and the channels, often we see them cut into the ice and then also in the rock. Like the same channel cuts the rock and the ice. So it seems likely that whatever process is forming it is able to carve channels into ice and into rock, which the easiest explanation is the ice is turning to liquid and eroding these things.
So what would it take to find some kind of evidence of liquid water in this ice?
I think unfortunately, the only way might be to send something there, because you could detect it remotely using radar, and people have done that on the Earth, but you still have to get kind of close. So it could be on a helicopter, for example. So it turns out the same kind of radar that's on a backup camera of a car, you can use that to detect liquid inside of ice, and people have done that for the army and stuff on Earth. And so, but again, you need to be kind of close. So you could stick one of these radars onto a helicopter and then fly close by. That way you're not disturbing the environment as long as you don't crash. And then maybe you can detect the liquid there. Yeah, from orbit, because you could detect liquid at the surface from orbit, but we don't think there's any liquid at the surface. So, yeah.
So you're proposing a version of Ingenuity with some kind of, would you say it was a radar scanner, and it would be able to fly? But that's a fairly power hungry piece of equipment, isn't it? You got to send out a pulse, receive the pulse. You pay the inverse square law twice to be able to get your signals back. Have you done the math on what is the smallest possible system and whether you could run it on a helicopter?
I haven't done the math, but I imagine if you can do it in a car, I think that the car ones are pretty small these days. So I imagine it's doable. And then that's one option. And the other one is if you actually land with a rover that can drive up to these things, and then that has more of a power bank resource.
And you just drill,
or at least first look at it remotely so you don't disturb it and haven't induced any heating or things like that with the radar if you can. And then yeah, if you must, then you should drill and at least expose the ice if it's not exposed already to study it.
And like, we know that this ultraviolet radiation, sunlight, is having a long-term effect on Mars. Like the top of the regolith is filled with perchlorates because of this ongoing ultraviolet radiation reaction that's going on Mars. So do you think it's possible that there's like a huge amount of this, or would it just be in like really special conditions, small pockets?
When you say huge amounts of this, you're referring to
The liquid water. Like, is there liquid water everywhere, just under the surface, as far as the eye can see? You just have to scrape away a little bit of that regolith and you reveal the old ice cap.
Yeah, so there's a third of Mars does have ice below the surface, but it's all buried. If it's buried, that means there's no sunlight heating it up to melt it. So the liquid could only form when it's exposed. And there's a student I'm working with at Arizona State University, and she's actually mapping out all the places where it is exposed today so that we have a map of here's exactly where we should look if it's melting. And turns out it's not one place or 10 places, it's actually hundreds of places. So there are hundreds of places, more in the south than in the north because there are more channels and steep slopes where this ice is sort of pasted on these walls. And yeah, so I think there are lots of places, but the amount of water will not be in thickness wise. Previous simulations suggest something like a few millimeters per day. But when you average that over a large area, that turns out to be a lot. So, yeah.
Now, you're not an astrobiologist, but you must have talked to some and said, I've found a possible location of liquid water on Mars that's getting sunlight that could provide photosynthesis. Does this work for you? What do the astrobiologists say?
Some are excited. Some say that photosynthesis is more advanced life. And so you would need, from our Earth knowledge, you would need simpler life to start out with and then gradually evolve into life that does photosynthesis. So that's one thing. And then the other thing is they ask about how long would the life be able to survive if it's, like I said, if it's buried under dust, then there's no liquid, there's no heating, it's just frozen. When it gets exposed, that could start up again. And so how long could it be dormant for and then come back? And cyanobacteria seem like a good candidate from people I've spoken to. And you also see them in similar environments on the Earth in these cryoconite holes, which we might talk about. And so there's that. And they are excited by the fact that, because for the longest time it seemed like, there's no hope for finding life today. It's maybe there was life before, and the question is what happened to it. But I think, what we're finding is that actually they could be still exciting places, and we've not been to these places yet.
Yeah, there was an interview that I did a couple of years ago about sort of something fairly related, just about, like, say you get a crater, like a brand new crater gouging out a chunk of Mars, and it exposes life within the crater. How long has that life got before that ultraviolet radiation wipes it out? And it's not quick, but it's not tens of millions of years. It's probably got a few 100,000 to million years before the radiation gets it all. And so you're sort of thinking, if it is protected by this layer, then it's got a much, as long as this stuff's protected, it's almost like it can hibernate forever until the right conditions return.
Yeah. And again, this is all ifs and buts and maybes, but if it's there on Mars, then maybe it could adapt to enjoying or using more of the radiation than we think it needs. So that's another possibility. But of course, we don't know. So
Right. So then, NASA comes to you and says, okay, we've got a helicopter mission, maybe a little mini rover. We really want to search for this. What's your best spot? Do you have a location that you think is the most interesting, where you would just be like, it'd be your top one, your number one choice?
Yeah, it's this place I mentioned earlier. It's in Dow Vallis. It's at 33 degrees south. Um, it's where, yeah, Phil Christensen, again, my advisor in 2003, he wrote this paper saying maybe gullies on Mars form from snowmelt. And it looks like there's these buried patches of snow right next to these gullies or channels. And when I began working for him, he basically said, I wrote this paper 20 years ago, prove me wrong. I'll see you at the end of the summer. I was an undergrad. And I think he's right, actually. And the first place I looked was that spot. And it turns out there was a new image from the better resolution camera, HiRise, from 2009 that no one had ever seen. And there's still countless images of Mars no human has ever looked at. So discoveries waiting to be made. But in that image, it looked like, oh, there's actually ice exposed exactly where he said there should be. You just couldn't see it in the old image. It was blurry. And I think that place is very exciting. And we actually got another image in 2020, and we see the ice has gone away, and a new channel is formed right where the ice was, again, suggesting that the ice has melted to carve these channels. And it's happening in 10 years, which normally in geology thinks like thousands of years. So I think that place is pretty exciting. Also, one other thing is it's in Dow Vallis is in this deep area, so the pressure is higher there. So if you form liquid there, it won't boil as easily, which means, and boiling just accelerates the loss of water if there is any liquid at the surface. And then from orbit, the temperatures we see are like close to the melting temperature anyway at the surface. So, which is what you see on Earth when there's melting below the surface. The temperature of the surface might be something like -3 centigrade, but then below the surface, 20 centimeters down, it may be 0. And we're seeing from orbit that these places, like in Dow Vallis at 33 south, the temperature of the surface is around -3/4 centigrade. So that is within the ballpark of what you need. So I think, yeah, I would say go there, send Arnold Schwarzenegger, get to the chopper. Yeah.
Right. With a chopper. Yeah. That sounds amazing.
Mhm.
So these kinds of, like, are there places on Earth that you could walk around that would feel very familiar to these kinds of conditions on Mars?
Somewhat. Yeah, there are places in Antarctica, definitely, where people have seen the subsurface melting happening, where, like I said, the winds are very strong. They blow off the snow, expose the bare ice, and sunlight goes in, heats on the inside. And then also on a lot of glaciers in high altitude, maybe just preferably in high altitude regions, again, where it's windy. And if there's dark sediment, which often there is, then they form these things called cryoconite holes, which I was alluding to earlier, where it's this dark sediment that sits on the ice, forms slightly differently in that the ice is already there, the sediment's on top, the ice is dark. The sediment is dark, and it absorbs the sunlight, melts into the ice, into liquid, gets to some depth at which the sunlight can no longer heat it enough so that it keeps sinking. But now it's stuck into the ice, and then every winter, the sunlight goes in, heats around that dark material, forms liquid, and then often in the dark material, there's life already there, like algae and cyanobacteria that fell in. And then liquid forms, and they come alive in the summer. And then in the winter, everything freezes up, the algae and bacteria go dormant, and then this restarts the next year. So you can see them, on glacier surfaces, the Greenland ice sheet, and in Antarctica.
And I know that this is kind of related. People have proposed, like, we get 100 tons of dust landing on the Earth every single day, and this dust is sort of randomly sprinkling around the Earth. But some of it is falling in Antarctica. And times when we went through, like, ice ages, like global ice ages, this could have been the only source of material and a way to keep life alive, that you would have had this material falling down on the surface, collecting, forming little, I forget what's the name for them, the holes? Cryoconite? That's the term? Okay. Yeah, so you get this space dust forming these cryoconite holes that are then keeping the life alive on the surface of Earth, waiting for the great melting for the life to be able to come back. And I really like this idea that, you can, even when you think that everything is completely frozen, in fact, you can still have, because there's this constant influx of material. And on Mars, you've just got dark dust blowing around. But on Earth, if the whole planet was covered in ice, you would still have a system that was trying to keep life alive and keep the melting happening.
Yeah, exactly. So that's kind of where this idea also came from, is like these snowball Earth events and how life persisted through them in the ice. Yeah,
That's really interesting. Yeah.
great.
What are you obsessed with right now?
The Beatles, John Lennon.
Yeah.
And work-wise, I mean,
No,
yeah,
I mean, if it's music wise too, are you going back through the catalog?
yeah. Well, yeah, because I used to be a fan of this band called Dream Theater, which is like progressive rock metal. The lead singer is from Canada, James Labrie, and it's complex instrument, long songs. And then last few years, my friend has been showing me the Beatles, and I didn't like them as a kid, but I love them now. And so I play guitar and trying to learn how to sing and play at the same time. And yeah, I've loved listening to John Lennon's stuff, especially. And work-wise, just the goal is trying to make better simulations of what is happening to ice on Earth as well as Mars. And then importantly, I found that some people who've studied things on other planets have not gone through and actually tested their simulations with data from the Earth, which I think is very important to do, because otherwise the simulation is just a random number. How do you know it's correct? Maybe the physics is correct, but how do you know until you check? And it's easy enough, like you said, we know the gravity is 1/3. You can change the gravity, and the parameters are all universal. So I think, you should always check whenever you can. So I'm collecting a bunch of data from the Earth, and so that's been fun, so that we can improve and make sure our models work before we apply them to Mars.
Have you had a chance to go to those places in Antarctica?
Not yet. My colleague, Steve Warren, who's at the University of Washington, he's like the world's expert on snow radiative transfer, how sunlight deals with it. And he just came back from Norway and kind of spoke on my behalf to see if we can work with them to go to these Antarctic areas to study them. So he's actually came back today, so I'm going to meet him on Thursday.
That's great. Yeah. Well, let him know that it's getting a lot of press coverage, and then
I will.
That will help push things over the edge. Yeah. Mm-hmm. Awesome.
Yeah.
All right. Well,
send us money to go to Antarctica. Let Fraser know.
Yeah. Well, good luck with the search, and hopefully you will get that call from NASA ready to send that helicopter to just because it sounds like the perfect target for
hopefully,
Mars helicopter.
You just need to demonstrate the liquid is the sticking point. I think people don't believe fully that it's possible, so that's the key. And then, of course, we're not in the best funding environment right now, so hopefully your work by promoting the importance of science will help demonstrate to people in everyday life that it's important.
Well, I'm doing my part. Thanks a lot. Good luck.
Yeah. Thank you.
I hope you enjoyed that interview. It's a pretty fascinating idea. And if you needed like more reasons to send a helicopter to Mars, I don't know what else it's going to take. Let's send more helicopters, fleets of helicopters to Mars. Now I'm going to give you some final thoughts, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bear Lake Roofing, Brian Bodie, Carolyn, Chuck Hawkins, Commander Balick, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pearl, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smith, Michael Purcell, Modsell, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Thomas Ilskadron, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I referenced a bunch of interviews that I've done in the past and how they've sort of informed my thinking as I was having this conversation with Dr. Khuller. And so one of these is this idea that cosmic dust is constantly hitting the Earth. And as I said, about 100 tons per day. And so no matter how badly the planet goes, how much it gets covered up in ice, you've still got this steady amount of material that's falling from space and could be creating these holes that we talked about in the episode. And then also providing nutrients for life to survive on the surface. Not thrive, but at least survive. And then the other interview that I did was about searching for places on Mars that are relatively fresh impacts, and that these might be the places where you've got recently excavated material that gets down through this toxic perchlorate and could be a place where you might be able to find life on Mars. That we should go for these fresh crater impacts first when we're looking for life on Mars. So those are two interviews that I think you'll really enjoy and will give you context for the conversation that I just had. All right, we'll see you next time.